Hey Math 20-1s, we're going to look at trig functions of angles and standard position today. So you guys have this slide. I would like you to calculate each of the values to 4 decimal places. Pause the recording and do as I ask with your calculators, write them all in, and then restart this. These are the values you should come up with. We notice that for every row of sine angles, the ratios are the same except for a positive and negative sign. If you were to look closely, each of those angles in the first row, sine 43, sine 137, sine 223, and sine 317, have the same reference angle. Row 2, all the cosine angles, all of the same reference angle, and you notice their ratios are all the same except for positive and negative signs. And tangent quadrant, the third row, all have the same reference angles, and they've all got the same values except for positive and negative signs. Reference angles have something to do with this, and depending on how big the angle is, tell us whether it's a negative or positive ratio, and depending whether it's sine, cosine, or tangent. So let's look at these a little more in depth using something called the cast rule. Now the cast rule tells us where each trig function is defined as a positive value. So if I draw my coordinate plane, I draw angle and standard position in quadrant 1, and I'll label that angle theta in standard position. If I make a right angle triangle, I'll label the sides of this triangle as x, y, and r. So x makes sense, I'm going in a positive x direction. Y makes sense, I'm going up. So that's a positive y. And we're always going to say r is a positive value. If I now state the trig ratios for the sine of angle theta, the cosine of angle theta, and the tangent of angle theta, here's what we come up with. Sine is positive y over r, cosine is x over r, and tangent's y over x, just like our grade 10 rules taught us for right angle trigonometry. If I go over to quadrant 2 and draw angle theta 2 in standard position, I'll notice that angle's got the same reference angle as theta 1. So if I make my right angle triangle and I label this right angle triangle with my x's and y's and r's, I'll notice I now have a negative x, a positive y, and the r stays positive. So we're saying theta 1 here is the same as the reference angle right there. And if I look at that, I notice sine becomes y over r, cosine now becomes negative x over r, tangent becomes opposite y over adjacent negative x. If I now make an angle in quadrant 3, in standard position I'll call that theta 3, but the reference angle, again, is the same as for theta 2 and the same as for theta 1. I now finish labeling the sides of this right angle triangle, and I notice x is still negative, y becomes negative now, I'm going down, and r is going to stay positive. So my trig ratios in this quadrant, theta 3, the sine of that becomes negative y over hypotenuse r, cosine negative x over r, and tangent will become negative y over negative x. Quadrant 4, same idea, draw angle in standard position, we'll call this theta 4, complete my right angle triangle, x is still positive here, this leg now becomes a negative y, and my hypotenuse is positive r. And my trig ratios for theta 4 are as follows. Sine is negative y over r, opposite over hypotenuse. Cosine, positive x over r. Tangents, negative y over positive x. All right. If we have a close look at all those ratios, we'll notice that every quadrant has 2 negative ratios except the first one. And our cast rule can tell us where all these angles are positive, where the trig ratios are positive. So next slide will tell us that. Therefore, given a coordinate plane, all trig ratios are positive in quadrant 1, only sine is positive in quadrant 2, only tangent is positive in quadrant 3, and only cosine is positive in quadrant 4. So there's our cast, C-A-S-T. All right, tells us where the trig ratios are positive. Having seen that, let's write each expression relating the function to its reference angle. So a 310 degree angle is in quadrant 4, we know that. the reference angle of 310 degrees should be 50. And in quadrant 4, the only ratio that's positive is cosine, so sine would be negative. So therefore, sine of 310 is the same as negative sine 50. Reference angle of 310 is 50, and in quadrant 4, sine is negative. Look at cosine of 290. Reference angle of 290, figure that out. Looks like it's 70 degrees. And cosine, 290 degree angles in quadrant 4, cosine is positive. So this one should be, cosine of 70 should be the same thing. If we look at the tangent of 125, 125 degree angle is in quadrant 2, so tangent is negative. So this should be negative tangent. And the reference angle of 125 degrees is 180 minus 125. So that reference angle should be 55 degrees as the reference angle. So tangent 125 is the same as negative tangent 55. And finally, sine of 150 degree angle is in quadrant 2. Sine is positive, and then we just have to figure out the reference angle. So this should equal the positive sine of 30 degrees. Beautiful. All right, moving on. Let's look at some special triangles. I've got a 45, 45, 90 degree triangle. Let's label it as such. If I want to say this isosceles then, because I've got two equal angles, then these two sides must both be the same. If I label both these sides as length of 1, then my hypotenuse would be root 2. And if you use Pythagorean theorem, you will know that that works out correctly. All right. If that's the case, then what are the trig ratios of each of these angles? Well, the sine of 45 degrees would be opposite over hypotenuse, 1 over root 2. Cosine of 45 degrees would be adjacent over hypotenuse. And tangent of 45 degrees would be opposite over adjacent, which is the same as just saying 1. If I look at the special triangle 30, 60, 90 degrees, and I label this one appropriately, let's watch what happens. I've got an equilateral triangle. If I come down here at exactly 90 degrees, that was close, make my right angle there, I've now cut this angle in half, and if it was equilateral, both these angles were 60. So if all the angles were 60 and I cut this exactly in half, these two angles become 30. And I've got a 30, 60, 90 degree triangle. Let's label this side as 2. So if all the sides of this equilateral triangle were 2, and I cut this angle in half, that means I cut this side exactly in half. That means these two sides are the same length, and they're both length 1. So if I use Pythagoras' theorem, 2 squared is 4, take away 1 squared is 3. That means this side here is root 3. And then again, I can label all my trig ratios for these special angles. Sine, cosine, tangent of 30, sine, cosine, tangent of 60. So these would be the ratios we get if we look closely and follow along. Nice to have these memorized, but if you don't, you can easily draw the triangles and figure out the exact values of these special angles, 30, 45, and 60 degrees. Let's also look at 0 and 90 degrees. Look at the values for sine 30, sine 45, and sine 60. What's happening as the angle increases? Well, as the sine angle increases from 30 to 45 to 60, the ratio gets larger. So if I were to check on my calculator, the sine of 0 is actually 0, and the sine of 90 has a value of 1. And 30 is closer to 0, 60 is closer than 1. It's going to work every time. So sine increases in value for the ratio as the angle increases. What happens to cosine? Well, if you look at cosine, the cosine of 30 is larger than the cosine of 45, and that's larger than the cosine of 60. So as my angle increases from 0 to 90, the value of the cosine ratio actually decreases. So the cosine of 0 has a value of 1, and the cosine of 90 has a value of 0. And if we look at our tangent ratio, again, as the angle increases from 0 to 30 to 45 to 60, the tangent ratio increases. If you check the tangent of 0 in your calculator, the value of tangent 0 is 0. If you check the value of tangent 9 on your calculator, it'll give you an error. If you check 89.9, it gives you a very, very large value. And you check 89.999, which is very close to 90, it gives you a very, very large value. So the tangent of 90, we say, is so large that we can't define it. So it's undefined. Haha. So let's use these special angles and the information in the last two slides to use the cast rule and come up with some exact values. So the exact value for the sine of 300 degrees. Well, like we did before, the sine of 300 has a reference angle of 60 degrees, and it is in quadrant 4. So in quadrant 4, the cast rule tells us sine is negative. So I could say the sine of 300 is the same as the negative sine of 60. If I look on the last slide, or a couple slides ago, I know what the sine of 60 degrees is. The sine of 60 degrees is root 3 over 2. So I want the negative sine of 60, so I get negative root 3 over 2. So the exact value for the sine of 300 is negative root 3 over 2. Let's follow along to the same thing for the cosine of 150 degrees. The reference angle for 150 is 30 degrees. 150 degree angle in standard position is in quadrant 2. We know cosine should be negative in quadrant 2. So I could rewrite cosine of 150 as negative cosine 30 degrees. If I look what the exact value for the cosine of 30 degrees is, I notice that it is also root 3 over 2, and it was negative cosine 30, so it should be negative root 3 over 2. That's the exact value for the cosine of 150. If we get a little more complicated, 2 times the sine of 135 squared times the cosine of 240. So let's rewrite the same thing as we've been doing, and then we'll do the operations on the ratios. So the sine of 135, well, 135 degree angle has a reference angle of 45 degrees. And in quadrant 2, where 135 is, sine is still positive. So I could rewrite that as 2 times the sine of 45 squared. And the cosine of 240 has a reference angle of 60 degrees. And in quadrant 3, cosine is negative. So I would say sine of 45 degrees squared times negative cosine of 60. All multiplied by 2. So now what's the ratio for the sine of 45? That's 1 over root 2. So I go 2 times 1 over root 2 squared, and the cosine of 60 is also 1/2. So that's going to be negative 1/2. So 2 times 1 over root 2 squared times negative 1/2. Well, 1 over root 2 times 1 over root 2 is just 1 over 2. So 1/2 times 2 is just 1, and 1 times negative 1/2 is negative 1/2. Excellent. Let's look at D. Same setup. Tangent of 315. Again, we're going to find the absolute value of, we're going to find the reference angle of 315, which is 45 degrees, and 315 is in quadrant 4, so it's going to be negative tangent of 45 degrees. This is going to be, we've done this one already, sine of 45 degrees, and this has a reference angle of 45 degrees, and in quadrant 4, cosine is positive. So we should have negative tangent 45 times sine of 45 times the cosine of 45. And tangent 45 we know is 1, so I've got negative 1. Sine of 45 is 1 over root 2. Cosine of 45 is 1 over root 2. Work that out, we get negative 1/2. You guys try E on your own, see how you do. Here's what you should have finished with. There's all the work. If you're not sure, you can ask the next day in class. That's going to be the end of this recording. We're out of time. There's no assignment, but I would like you to look at the next one. The next lesson is going to be solving trig equations, and there'll be an assignment after that which takes into account everything we've done here. All right. So until then, we'll see you tomorrow.